So in this video, we're going to kind of continue on for rational exponents. We're going to have rational exponents where it's just not 1 in the numerator of the exponent. What happens if we have other numbers and how to simplify that. So you can rewrite, or you can write a rational exponent as a root and vice versa. You can switch it around. And then you can just simplify the expression of all rational exponents. So remember, we learned that rational exponents is just when you have a fraction in the numerator, and that indicates that we are dealing with roots. So from the activity, so your second activity, which you should have did before this video, we had something else besides 1 in the numerator of the exponent. And what happened is that this, remember, is your index. This is your radicand. So we have x, we have nth root, and then we put m here. Or we learned that we can write it as the nth root of x to the m power. These three statements are all equivalent. So same here, if I had this, that's the same thing as if I would write the p root of y to the r, which if I want to write it as an exponent is to the r p, y to the r over p. And similarly with fractions, we can write expressions. So if I have g to the h under the radical, b would be my radicand, and I can take it to the a power, or I can write it as the b root of g to the h, and the a can be on the inside. And you can split it. That was also something you discovered in the activity, but I'm not going to waste time in the video to write all those out because there was about 2 other, maybe 4 other options. So here, just reversing it, I have my denominator and my numerator. But again, I can rewrite this as a over b to the k root to the h, which is a over b to the hk. Alright, so we're going to simplify expressions using these rules. And one thing, I have this question, does the order matter? Does it matter if you do the root and then the power and the power and then the root? And the answer is no, and I'm going to show you that. However, there is one that seems to be easier than the other in most situations. So I'm going to show you both ways. So here's number 1. We're going to do the root first and then the power. So I can write this as the 4th root of 16, and then I can cube it, or the other way is that I can cube it and then take the 4th root of it. Alright, so let's see which one is easier. So if I do the 4th root of 16 and I want to break this down, that's 2 times 2 times 2 times 2. So this is 2 cubed, which is 2 times 2 times 2, which is 8 as my final answer. Now if I do 16 cubed, which I need my calculator because I don't know that one off the top of my head. So if I go 16 times 16, 16, let's find 1. That's 4,096. So I still have the 4th root of 4,096. Well, I need to break this down. Well, I know this is 16, I believe 250. Ooh, I need to figure that one out too. Alright, so 4,096, if I divide that by 16, is 256. Alright, I was right. Alright, so 256. Alright. And then I can break these down into 4 and 4, 2 and 2. So there's one set of 2's. And here, I know it's 16 times 16, 4 and 4. 2 and 2, 4 and 4, 2 and 2, which gives me 8. So think to yourself, which one took a lot more work? The first one where I did the root and then the power, or when I did the power then the root? Well, by time-wise, one is easier. It's always easier to do the root than the power, or it's quicker, I should say. There's just less involved when you're doing it. So I'm going to do the root then the power. If you want to do the power and the root, again, it does not matter. However, if you like to save time like I do, it's easier to go small and then big. Alright, so on this one, I have 36, so my root is 2, so I take the square root of 36, and I'm going to take that to the 5th power. Square root of 36 is 6. 6 to the 5th power. Well, I'm going to use my calculator. We have 6 times 6 times 6. 5 times. Give me 7,776. So in this one, I have the 5th root of 243. And then I need to square it. 2 is going there, 5 goes to your index. So simplifying this down, I know 9 goes into it. And that's 27 times 3, 3. It's looking like 3 is going to be our number. So 5th root of 243 is 3. 3 squared is 9. On this one, our fraction one, we're taking the square root of 16 over 81, and then we're going to cube it. Alright, so square root of 16 over 81, these are both perfect squares. So square root of 16 is 4, square root of 81 is 9, and then we're going to cube. I know 4 cubed is 4 times 4 times 4 is 64. 9 times 9 times 9 is 81 times 9, which would be 729. Alright, so review. Rational exponents are roots. Order doesn't matter, but it's usually easier to go smaller than bigger. So it's easier to do the root part, when we don't know the index, and then do the exponent. It will save you more time when you're doing this on your worksheet. Reminder to do reflections. You get credit for watching this video.